Hey everyone, so let's understand how you can identify hallucinations, reasoning errors and biases in the LLM output. Now, as part of this tutorial, we'll understand what are the techniques to identify these hallucinations and reasoning errors and biases, these defects. And then there are a couple of hands-on exercises, experiment with hallucinations in testing with GenAI and reasoning errors. So we'll try to generate or try to figure out the hallucinations in very popular generative AI tools. So you can easily identify those when you are using generative AI in your software testing projects. So let's understand what are the ways to identify these defects. So effective integration of the generative AI system into software testing requires the ability to detect hallucinations, reasoning error and biases in the LLM output. Why? Because when you are using the generative AI solution in software testing, you should be aware, you should be able to identify whether the output that you are getting is actually correct or hallucinated, or it has the reasoning error, or it has the biases. So there are certain techniques to identify that, and we'll understand those one by one. So generative AI system can produce hallucination, reasoning error and biases, and these effects reduce the quality, first thing, of the generated test, where anything that you generate in software testing from GenAI, the quality will be reduced, compromised, and you won't be able to use it. It's not of good quality, right? And then effective integration requires testers to spot and mitigate these errors. Detection methods vary depending on the type of the defect, whether it's reasoning error, whether it's bias, whether it's hallucination. So you will be able to detect with different methods depending what type of error it is or defect it is. Then detection method can also be applied through review or a mix of review and automated verification. So let's understand how you can identify. Now, for detecting the hallucination in GenAI, first thing, hallucination is factually incorrect information, irrelevant information output being generated by the GenAI. It can mislead testers and compromise test validity. So any incorrect or factually incorrect information, irrelevant output by the GenAI is hallucination. How you can detect these? So hallucinations can be detected with following approaches. First thing is cross verification, wherein you compare outputs with requirements, documents or known system behavior. And this is where as a tester, your input and your knowledge comes in picture. You cross verify with existing requirement whether the output is actually matching with what input you have provided, with the user story that you have provided, what the requirement says, or it is actually providing irrelevant output and not related to what the requirement says. So cross verification is the first thing, which is manual verification. Then domain expertise consultation. Your subject matter experts, SMEs in your organization, your team, can help to validate the accuracy of the output or what GenAI is producing. So they can catch nuance inside that automated systems might overlook. So consulting your domain experts, that's another way. So making sure that you actually have domain experts that can guide you and can make sure that the output that is being generated by GenAI is actually factually correct and relevant. Then the third way is consistency check, where ensuring outputs align with each other and known facts. How you will know this? When you yourself have knowledge. Now, currently in market today, people think that, software testing will go, development will go completely. But remember one thing, your generative AI or any AI that is available in the industry at the moment is not going to replace any person. It's only going to enable you more. So you will only get replaced if you don't know these technologies and limitations of these technologies. If you know the technology, you will know how to use it, expedite your work, and you will be better than all other people who are not learning. And those are the people who will be get laid off. So consistency check is all about your knowledge, your information. Can you see that the output is actually correct based on what you have learned, what your experience is, based on the facts, right? So in terms of example, system must support password reset via email. So for example, this is the requirement we have provided. AI might hallucinate and system also supports biometric reset, which is incorrect assumption. You haven't provided this assumption. So if you are providing the user story and AI is providing you the test cases for the user story, whatever is mentioned in the user story, as well as it is adding a lot more information that is not not relevant in the context of the user story, then you know that the output is hallucinated. So you know what to use, what to grab from that output and what not to grab, or updating your prompt so that AI provides you the correct information and not hallucinated information. Okay, so these are some of the detection techniques for the hallucination. Then reasoning error detection. What are the reasoning errors? So reasoning error is when the logical structure is being misinterpreted by the AI. Conditional logic, step-by-step reasoning, anything that is being misinterpreted, because AI relies on the pattern matching and not true reasoning. So reasoning error detection approaches logical validation. You do the logical validation. So you evaluate the logical flow, that is the consistency, coherence and structural reasoning within the generated text of the AI generated content, and see that it is coherent and consistent or correct through review cycle. So you see whatever has been generated, it actually makes sense. It is coherent, it is correct, and it makes sense. So that's logical validation. Second thing is output testing. You run generated test cases, scripts against test objects to verify the results. So that's another way to detect the reasoning error. For example, if we talk about the task, I prompt that this is the task, prioritize test cases by risk and provide the test cases in the list, and also the user story in the list, and user story has the risk rating associated against or priority against the user stories. Now the AI should be able to see which user story or which test case is mapped to which user story, and from that list it should be able to prioritize those test cases. But AI might not be able to reason correctly and prioritize the cosmetic UI test cases over payment gateway test cases. So in this case, your judgment as a tester, your judgment and automated checks ensure logical soundness of AI generated testware. So this is how you are going to detect the reasoning errors. Now the bias detection, how you can detect the biases. Bias, again, from the training data limitations, outputs may favor certain perspectives or assumptions. That's the bias. How you can detect fair representation review. So this is one of the technique for bias detection. Reviewing that the generated testware, such as synthetic test data, is fairly and accurately represented relative to the test strategy. So for example, you have a test strategy, and your test strategy, within your test strategy, you have the requirement for the customer data across the globe, and you have wrote a prompt to generative AI to generate the customer data, customer name, first name, middle name, last name, and the address from 10 different countries. So you should be getting that information fairly, and that information should match to the naming convention. The address should match to the address details of those locations and countries. Okay, it should be dummy, it should be fake addresses, but at least the name, what sort of name are there in that country, that should be there. Okay, then test type balance, assessing biases related to test types, checking for underrepresented non-functional test cases. So if, say for example, you are trying to generate the test cases for few requirements, and you say generate functional test cases and non-functional test cases for these requirements, and you see the non-functional test cases are very limited, so that means the model is biased and not able to generate non-functional test cases against that criteria. So that test type balance, or another detection approach is test type balance, or checking the balance of the output. For example, AI trained mostly on English data generates test cases ignoring localization needs. So Hindi, Spanish, other languages is being ignored. That's the bias in the model. So as a tester, you should be able to ensure that AI outputs are inclusive, balanced, and aligned with the test objective. So that's how you are going to detect the bias. So these are some of the approaches from the exam point of view. You need to make sure that you understand these approaches, because there might be multiple choice question around the approaches for the defect detection in generative AI. So that's all for this video. Thank you. I'll see you in the next tutorial.